Hi students, now we are going to solve the numerical problems in the textbook exercise. Problem number 1. A uniform disc of mass 100 gram has a diameter of 10 centimeter. Calculate the total energy of the disc when rolling along a horizontal table with a velocity of 20 centimeter per second. Take the surface of the table as reference. So this is only the surface of the table, okay? So it may be kept on the ground surface at some height, but we are going to take only the reference as the surface of the table. Okay, now we can look at the diagram. This disc is rolling on the table surface. So we have already studied rolling motion is a combination of two types of motion, namely rotational motion and translatory motion. So because of rolling, it has two kinetic energies. One is translatory kinetic energy and the other one is rotational. In addition to that, you can see that the center of mass of the disc is at some height from the table surface, that is equal to the radius. So it will have a potential energy in addition to the kinetic energy. So it has totally how much energy means 3. So kinetic energy of translation, kinetic energy of rotation and potential energy. So we have to add all the 3. Before that, you can read out the problem and get the given information. So the mass is given. Mass of the disc is equal to how much? 100 gram. So in kilogram, if I write means 100 divided by 1000 is 0.1 kg. So we will convert it into SI unit. Next, its diameter is 10 centimeter. So diameter is equal to 10 centimeter. So radius is equal to how much? 5 centimeter. This radius of the disc, 5 centimeter means it is 5 by 100. 5 by 100 is what? 0.05 meter radius, okay? And it's having a velocity of 20 centimeter per second. You can see that the translational velocity is equal to the velocity of the center of mass. So this is given as 20 centimeter per second. So this also I will convert in meter per second, means this will become how much? 0.2 meters per second. Okay. Also its angular velocity is omega. It is related to the linear velocity by the expression v is equal to r omega. So this implies omega is equal to v by r. So these are all the required informations we have grouped separately. Now, kinetic energy, translational motion, okay, due to translatory motion, what is its kinetic energy of the disc is equal to half m into v square, okay, let it be as it is. Now, kinetic energy of the disc due to its rotational motion, with respect to the axis, okay, so now this is equal to half into I omega square. Half into I omega square. Okay. Now moment of inertia of the disc we have already studied, is it not? Moment of inertia of a circular disc. Okay. So this is equal to mk square. So this is equal to m r square by 2. So this is equal to m r square by 2. So in place of I can substitute half m r square. So now this is therefore kinetic energy of rotation. Okay, kinetic energy due to rotational motion is equal to 1 by 2 into, instead of this I can substitute half m r square. So this is 1 by 2 m r square into omega square is there, is it not? Omega is how much? V by r. So this will become v square by r square. V square by r square. Okay. Now this r square and r square get cancelled. So this will be equal to 1 by 2 into 1 by 2 is how much? 1 by 4 mv square. Okay. So already we have got one equation for kinetic energy translatory motion, that is half mv square. Now kinetic energy due to rotational motion is how much? 1 by 4 mv square. Okay. So if I add these two, that will be the kinetic energy of the rolling motion. Is it not? The kinetic energy of the rolling motion. Anyhow, let it be as it is. Now its potential energy also we can find, that is equal to what? mgh. Okay. So this is now equal to m, mass is 0.1. So this is a 0.1 into 9.8. And here at what height is the center of mass of the wheel? That is equal to what? Radius. So mgh also can be written as mgr. Okay. So for radius I will substitute here. The radius is what? 0.05. So this is 0.05. Okay. Now you will see here 0.1 is 1 into 10 power minus 1. And this is 9.8 can be written as 98 into 10 power minus 1. And this is 5 into 10 power minus 2. So this can be written as 10 power minus 1 into 98 into 10 power minus 1 into 5 into 10 power minus 2. So finally you see 98 into 5 is 490 into 10 power minus 4. 10 power minus 4. So potential energy alone is now equal to 490 into 10 power minus 4 means 0.049. 0.049. Is it not that? So this is 0.049. The unit is joule. Like that I am going to add kinetic energy translation and kinetic energy rotation. Okay. So kinetic energy translatory plus kinetic energy rotation. So this is equal to half mv square plus 1 by 4 mv square. So that this is equal to half plus 1 by 4 is how much? 3 by 4. So this is 3 by 4 mv square. So this is equal to 3 by 4 into the mass of the disk is 0.1. So this is 0.1 into v square. V square is how much? 0.2 into 0.2. So this is 0.2 the whole square. That is 0.04. 0.2 the whole square is 0.04. So this 4 and 0.04 can be cancelled. So this is 0.01. So this is 3 into 10 power minus 1 into this is 10 power minus 2. So 10 power minus 2. So that this is equal to how much? 3 into 10 power minus, this is 10 power minus 2. So totally this is 3 into 10 power minus 3. So this is equal to how much? This is equal to 0.003 joule. 0.003 joule. So total energy, therefore total energy is equal to kinetic energy translatory plus kinetic energy rotation plus potential energy. So the sum of the kinetic energy translation and rotation we have found, that is equal to how much? 0.003 joule. And potential energy how much is? We have calculated 0.49 joule. Now we have to add these two, so that this is now equal to 0.049 plus 0.003. Okay, so this if you add means 9 plus 3, 12, remainder 1. So 1 plus 4 is 5, and here there is a 0. So this is 0.5 0.052 joule. 0.052 joule. So this is the total energy. What do you mean by total energy here? It is the kinetic energy due to rotational motion plus translatory kinetic energy plus potential energy. So this is the final answer. I hope you must have understood well. Fine.